Aha, there we go. Okay everyone, welcome to Kerbal Space Program, one of my favourite games on the PC. Absolutely brilliant little game this. Well worth it. I think it's certainly, as of the moment it's in the Steam sale, or it certainly was. Great little game. For anybody who doesn't know Kerbal Space Program, you basically get to build spacecrafts, build rockets, send your Kerbals, which are little green men as you can see, into space. You get to land on the Mun rather than the Moon, and you can go to all sorts of planets and do all sorts of cool stuff. So it's really fun, this game. A little bit sciencey as well, a little bit of education, but a lot of laughs along the way. Things will explode, things will blow up. It's all good fun. What we're going to do in this series, we're going to have a look at some missions, basically things I'm making up, things that I want to do. There's several game modes that you can play. You can have like a career mode called First Contract, where you have to fulfill contracts and unlock things. We're not going to play, we'll probably do a playthrough in a separate video series of that one, but we're not going to do that in this series. What I'm going to do in this series, I'm going to go into Sandbox. If you go into Sandbox, you have access to absolutely everything. It's, you know, nothing's locked. You've got all the parts. You can build whatever you want. You can do whatever you want. There's no limitations on things at all. The only downside is you won't collect science or be able to do anything while you're out there because you're in sandbox mode. But we're going to play this in sandbox, and our first mission is going to be orbital. So the planet Kerbin, which is a kind of Earth analogue. It's a bit smaller, and the gravity's a little bit different. But we're going to basically build a rocket that is capable of achieving orbit with a crew member, and that we can get back again. So very simple first mission for, you know, anyone who's never played the game before. So let's go in, and we'll start a game. I'm going to resume save because I already have a save game set up for this. There we go, Kerbal missions. So if we go in there. Obviously this is in sandbox, so everything is completely unlocked. If you go into starting career mode, as we'll see in a second when this loads, there we go. If you start off in career mode, this is the Kerbal Space Center. Things will be a lot smaller, and it'll look like it's been basically built out of bits of wood in a car park, and then you'll gradually be able to upgrade things and turn it into this, which is the fully upgraded Kerbal Space Center. As we're in sandbox though, we get it fully upgraded from the start, although a lot of this stuff doesn't do anything in sandbox mode. This is research and development, which is where you use your science to unlock new parts in career mode. Doesn't work in sandbox mode. And we've got various administration and things like that. So administration doesn't work. I think that's mission control, that doesn't work. Space plane hangar, that's where you build space planes and things like that, and atmospheric planes. I don't really do planes, if I'm honest, so probably won't be going in there. This is the astronaut complex, so this does work in sandbox modes, where you get to pick your Kerbals that are going to become astronauts. As it stands, you get these four. Jebediah, who is the uber famous Kerbin, Bill, Bob and Valentina. They are all your sort of core Kerbals, and I believe they are indestructible. If you somehow lose them, they will respawn. I've yet to test that. Well, I've killed them several times, but I've never actually seen if they come back. Basically here you've got Jeb and Valentina, who are pilots, and then you've got engineer and scientist. These basically allow you to do different things with your spacecraft. It doesn't affect you so much in sandbox mode. Certainly scientist doesn't really make much difference, engineer doesn't. Pilots unlock certain sort of features of the automatic stability system. If you have an experienced pilot on board, you can do more things, but I have a feeling that it's all unlocked in sandbox mode. So we'll come out there. We have to apologise if I'm a little bit sniffly. There's a lot of colds and bugs going around at work, and I've picked up just about every single one of them. Over here we've got the launch pad. That's where we'll launch our vehicles from. Over here we've got our tracking centre. We'll just pop in there and have a quick look at the map. Here we go. So there's Kerbin. At the moment we've got no flights in progress, so there's nothing listed down here, and we can't see the orbital paths of anything. There's the Mun, which we'll be going to in a future mission. There's Mimbus, which is the second moon, which we'll be going to as well. As you can see, Mimbus is on an inclined orbit, and if we come out even further, we can see there's our orbit of Kerbin, and here we have some other planets. There's Eve, Moho, we've got Duna, which we'll also be visiting, Drez. We've got Jewel, and out here we've got Elu, and obviously in the middle we have the Sun. And these various objects are sort of, I don't really know what they are. I think they'll probably be asteroids. Okay, so that's our basic tracking mode. We'll see a little bit more of that later. So we come out of here. I'm not going to do too much tutorial type stuff in this because you know, the best way to get the hang of this is just to play with it, really. Okay, here in the middle we've got the vehicle assembly building. That allows us to build our space rockets. So we're going to go in here and we're going to do that. Okay, again, I'm not going to turn this into too much of a tutorial, but a quick talk through the screen here. We've got this is our build area. Over here we've got all of our parts, so we've got various pods here, which include crewed pods that you have crew in, and unmanned probe pods, which allow you to control remote probes. If we come down here, we've got some fuel tanks of various diameters and sizes and types, because we have two different types of fuel that we're going to be using. Liquid fuel, which obviously is used for rockets, and RCS fuel, which is used for reaction control systems. If we go here, we've got engines, so we've got all these different types of engines for different uses, from little tiny engines all the way up to solid rocket boosters. We've got ion engines, which are sort of more sophisticated electronic engines, and we've got small liquid fuel engines. We've got a nuclear engine there, which we'll probably use on some of our longer duration missions later in the series, and we've got the really big powerful engines that allow us to get big rockets off the ground. If we come over here to command and control, we've got all sorts of things for stabilization, which we will be using. We've got reaction control thrusters and things like that. In structure, we've got all the various parts that we'd use to build rockets or to build things. So we've got, you know, octagonal struts, we've got adapters to go between the different diameters of rocket tanks and things like that. We've got stack separators and decouplers, which allow us to separate our rockets into stages. So if you think back to, say, the Apollo rocket or even the Soyuz, they separate, it jettisons various parts of the rocket as it goes up, and in fact even the space shuttle with the solid rocket boosters coming away, and the decouplers and things like that allow us to do that. So that's what they're for. If we go here, aerodynamics, this is really if you are building planes, but there is also some things in here which are useful for us. But in rockets, we've got protective shells for our unmanned probes. We've got some nose caps and things to go on rocket boosters, and we've got some stabilization and control fins, which we will be using. And also heat shields, quite important, otherwise you burn up on re-entry. So we'll have a look at those as well as we build the rockets up. If we go to utility, all sorts of various odds and ends really in here. We've got docking ports that we will be using, various different sizes, things like this we don't need to worry too much about. These are used for mining. We've got fuel cells. We've got landing legs, landing struts, landing gear for aircraft, which again we probably won't be using. We've got various parachutes, various different types, and all sorts of other bits and pieces. We've got service bays, which we may well be using later, solar panels, which we'll definitely be using, batteries, and things like that. So again, we'll go through all of this as we build rockets. The best thing to do is just have a bit of a play. I know I'm going through this rather quickly, but as I say, I don't really want to turn this into a tutorial. But basically how it works is when you build a spacecraft, you have to obviously have enough fuel on board to be able to complete what you're aiming to complete. That's essentially, it's almost what they call delta V. Delta V is your ability to change speed. It's basically how much ability to change speed or change velocity, more accurately, you have in your spacecraft, and you'll require a certain amount of delta V to achieve certain tasks. So a certain amount of change in velocity, and that is calculated based on the mass of the vehicle, the thrust output of the engine, the efficiency of the engine, and how much fuel you're carrying. So you need to make sure you have enough delta V to be able to complete whatever it is that you're aiming to do. And we'll start explaining that as we go along. You also need to make sure you have enough thrust compared to your weight, thrust to weight ratio, to make sure your rocket will actually fly. Particularly off the launch pad, you need to make sure that it's got enough thrust to get itself off the pad. So that's something else you need to keep an eye on. So you need to make sure the bigger the rocket, the more powerful the engines it's going to need. And you also need to make sure you've got power. The various modules and things like crew compartments particularly with remote probes that don't have crew in them, they all use power. The science experiments in career mode use power, so you need to make sure you have enough power on board. You can do that with batteries, but you will always need solar arrays as well. And if you're going further away from the sun, you possibly need to consider something else, and that's where you have fuel cells, and you also have a nuclear thermoelectric generator as well, which generates power where there is no sun. But again, we'll probably the best way, rather than sort of trying to explain it all now in detail, what I'll do is as we go along, you'll see how it all works, and you can have a play yourself if you get hold of the game, of course. Okay, so one last little bit which doesn't really affect us in sandbox mode. So for these missions, doesn't really matter, but I may well still put some of these various bits and pieces on the spacecraft. These are the science experiments. In career mode, the aim of the game is to collect science by going to various different places and performing experiments, and these are the experiments. So by running these in various different places, so in orbit of the planet, in high orbit of the planet, around orbit of a different planet, on the surface of a different planet, things like that, you can collect science, and that then allows you to unlock various tiers, which then unlock new parts which allow you to go further and get more complicated contracts and things like that. They don't really do anything in sandbox mode, but sometimes you still put them on there just for the fun of it, but they don't do a great deal in science mode because you don't gather science in science mode. So these are the various science experiments that you can run. We'll probably bung some of them on just so you can see them, but again, they won't do anything until we go into career mode. So that's it for the parts. There's a few other things up there which you'll see at some stage. Down here is your credits, so that's essentially your money. Again, we're in sandbox mode, so that doesn't make a blind bit of difference, but what it's going to tell us is basically how much this spacecraft is going to cost us to build and to fly, which is important in career mode but not so much in sandbox mode. Down here you've got the controls for symmetry. You'll see me using that as we start to build spacecraft. Basically, single dot basically means you're just going to put one of whatever it is onto your rocket. If you click it, it's probably not letting me do it because I haven't got anything selected, but you can let's just bung some stuff in here. So if I pop that in there, you can see now I can change that to dual symmetry, which will try and attach 2, or quad, which will attach 4, or that, which will attach a lot of whatever it is, so in this case a fuel tank. Yep, so that's how that works. So let's get rid of that by dropping it back over there. Here you've got controls for snap, so that either snaps it onto essentially prefixed angle points, or if you click on that and turn it to smooth, which will be a circle, you can basically put things anywhere you want around the radius of your rocket or spacecraft. We've got various different things which I'll show you for centre of mass thrust and lift when you're building rockets, so you can see where they are basically. Down at the bottom, not really critical for us. Again, this is an engineer's report that just tells us the size, height, width, length of our rocket and any problems that it might have that you just need to be careful of. Kerbal Engineering System is a mod that I've got added, which gives us a few extra little benefits and bits and pieces. Well worth putting it on there. It's called Kerbal Engineer Redo. Definitely a benefit to put that mod on there. That's Kerbal Alarm Clock, which is another mod, very useful, but we won't talk about that too much now. This is where your staging will come up, which I'll talk about once we start to build a rocket. And up here you've obviously got exit, go to launchpad, save, load previously designed one and create a new one, and we give our spacecraft a name up here, and we can switch between build and various setup and other options again. I'll talk you through all of this once we start to build rockets. So that's a very quick, and apologies, I know I've kind of really flown through that and gone very quickly. If there's anything you want to know about Kerbal Space Program's build system, drop us something in the comments and I'll do my best to answer it, and hopefully in the future I might be able to do an actual proper tutorial on how to build spacecraft, but for now we're concentrating on the missions. So what we're going to do, our first mission is going to be an orbital. We want to get ourselves into orbit, so what we want to do is build ourselves a spacecraft that's capable of being in orbit, and then we want to build ourselves a rocket to get it there. So we're going to start off by building our root component. 9 times out of 10 you'll notice some of these items are greyed out and some of them are not. Items that are greyed out are items that you cannot use as a root component, so that can't be the first part of a spacecraft, whereas that can. And then you can build around it, and that's your root item, but it's not going to be on this occasion. What we're going to start off with is we're going to start ourselves off with a pod, because I want to have a crewed vehicle, so I'm going to use this, the Mark 1 command pod. Okay, so if we click on them, pop one in. The Mark 1 command pod is essentially the Mercury capsule. You know, give or take, single Kerbal, simple, standard conical shape. So what we need to do is think very carefully about what we're going to get this little spacecraft to do. First off, this has essentially got a built-in heat shield, so you don't need to bother fitting a separate heat shield to the bottom of it. Not for simple orbital missions like this. Excuse me, that cough's been coming for a while. Yep, so we've got our simple pod. Don't need to bother fitting a heat shield to it because it's essentially got a built-in one. But first thing we need to consider, this thing needs to get itself back. Okay. In order to do that, we need to be able to separate it from everything else that's going to be connected to it. So the first thing we need to fit in the structural area is going to be one of these, a stack decoupler. If I pop that on the bottom, what this basically does, the direction of the arrow indicates the side that will decouple. You'll see down here we have an item in the staging diagram. When we activate this stage, what will happen is this decoupler will detach whatever is attached to the edge that that arrow points to. So in this case, the command module will detach. Anything below the decoupler will stay attached to the decoupler, but the command module will detach. That's how a decoupler works. So that allows us to separate the command module from the rest of everything else that's still up there. We need to build ourselves a spacecraft first off, and to do that we're going to need a fuel tank. We're going to need some fuel, little fuel tank, because we're not going to do much with this. We're just going to put it into orbit and get it back down again. To get it back down we need an engine. That's what the fuel tank's for. That will provide a little bit of fuel which will allow us to get ourselves back down. And obviously then we're going to need an engine. And we're only going to need a little engine. The engine I'm going to use is this one, the Terrier, which quite neatly is the same size and fits onto the bottom. So essentially when we get into space, that is our spacecraft. The rest of the rocket underneath it will have been jettisoned at that point. Obviously also we need to get this thing back down again. We need to land it safely, so on the top here we need to put a parachute. So if I come down here to utility, we'll find ourselves a parachute. Now we don't want to use a drogue chute. We don't want to use that because it's far too big. We don't want to use that because A, it's far too big, and B, it's a drogue chute, so it's not going to slow us down very much. What we want is this one. Neatly fits. It's designed for this module. Nice and neat, nice and tidy, fits on quite well. Okay. What else do we need? At the minute, not a great deal else. Okay, that's our spacecraft. For the sake of argument, I'm going to call it Mercury. It isn't, strictly speaking, because Mercury didn't have all this stuff on the back of it. It just had some retro rockets that fired, but, you know, closest we can get in Kerbal Space Program. Okay, next thing we need is our rocket. So, back into structural, another stack decoupler. This will allow us to detach the rocket. Okay, at this point as well, I want to start checking my staging, because if you look here, my staging is all over the shop. Okay, that will detach, and the next stage will ignite that engine. I kind of want those two to happen together, so let's drop that down there. So when I uncouple the rocket, that engine will activate. It won't necessarily ignite, it depends on what my throttle levels are, but it will activate that engine. Look at the next stage, the decoupler will fire and the parachute will fire at the same time. That's bad, because we're going to be detaching this whilst we're still in space, and we definitely don't want that to fire at the same time. So what we're going to do, bring ourselves a plus and drop that down there, so the parachute will fire separately to that, and the parachute will always be the last item in any stage diagram. Okay, so let's quickly save that. Now we need to build ourselves a rocket. So some fuel tanks. What I'm going to do, I've got the 800. Now that should be enough on its own, I think, for the upper stage of the rocket. So I go to engines. This is the one I want. L45 swivel. The swivel is vectorable, that is, you could steer it, which we kind of need because we don't have any other form of steering on this thing. When we detach everything else, the command module has something called torque built into it, which basically allows us to manoeuvre it around, essentially using gyroscopes. And because the spacecraft up here is quite small, that'll be fine, but when we've got the rocket attached, it don't work. So we need to use the engines to swivel. Okay, so there's our upper rocket. And if you look down here, this is actually Kerbal Engineering redo. We have a delta V of 3000 meters per second, thrust to weight ratio of 2.5. I'm actually wondering whether that would make it, whether that would actually make it, you know. That might even get into orbit on its own. Because it's got such a high thrust to weight ratio. I'm actually wondering if that would get into orbit on its own, you know. Do you know what? I think I'm going to try it. Let's just try it for the crack. Okay. So, something we do need though, we need to control aerodynamics. Otherwise we're really going to struggle to fly this thing. So probably the best ones to use are going to be these, the control winglets. But we don't need that many. Probably put 4 on. There we are. Pop those down there. So that just gives us a little bit of stability. And one last little thing that we're going to do, if I just grab that and drop it down, get close to the floor, and go into structure, you'll see we have a launch stability enhancer. I'm not going to put 4 of them on, we only need 1. And I'm just going to pop that there, and that will basically just stop the rocket from falling over on the launch pad. Right, I'm going to save that. Okay, let's just check our staging again. We need that and that to fire at the same time. It's very critical. If you've got a launch stability enhancer, you need to make sure the engine fires at the same time, otherwise the rocket will drop backwards and explode. So check your staging. Okay, let's try and do this then. This will be quite funny. I've not tried this before. I've not tried this rocket before. Whether this will work, I don't know. It'll go somewhere. It's whether it will get to orbit. In theory, it should, because it's got such a high thrust to weight ratio. I don't need to fire its engines at full throttle. Oh, this would be quite amusing if this actually makes it. Okay, we've got Jebediah on board. So this is our flight menu. Another quick little tour of this. These 2 little boxes up here are again Kerbal Engineering redo, but they are really useful for giving you information about what your flight is doing. We've got some things up here which we're not going to worry too much about. The only one we need to think about are resources. That just tells us how much charge, how much monopropellant, which we don't need to worry about because we haven't got any reaction control on this, and how much fuel we've got. This is our mission lapse time clock and our warp controller, which allows us basically to time accelerate. Here's our staging diagram. So these are, when we press the space bar, which is the stage key, this is what will happen with these various things. Don't need to worry too much about that. This is your main nav ball. You've got your throttle control here, and over here you've got G meter. If it goes into the red, you kill your Kerbal, so be careful. And obviously you've got your nav ball with your heading. We've got reaction control, which doesn't affect us because we've got no reaction control system on this rocket. And we've also got stability control, which we are going to turn on. That helps you keep the rocket stable. You really don't want to fly without that, believe me. And obviously then we've got our crew down here. We only have Jebediah on board. We can go IVA, which basically takes us inside the capsule. So we get a pilot's eye view. And we could go EVA, which basically he gets outside, but we're not going to do that right now. Up here we've got our altitude, our atmosphere, and that's about it really. So we have a quick look around. We're in daylight. If we press M, that takes us into the map. We just need to bring up the nav ball, and there we go. There we are on Kerbin. So we're going to need this in a minute. I'm going to do this the old-fashioned way and assume I haven't got Kerbal Engineering on here. So if we go back to the main view, I'm going to put my throttle at about 2/3 because I've got such a high thrust to weight ratio. I don't think I need it to be at full throttle. We'll find out when I press the spacebar. And away we go. So we're flying upwards. We're going to keep ourselves vertical. And we are flying. Okay, I'm just going to start to tilt very, very slightly. I'm not going to go over very far. I just want to tilt a little bit, just to start going east. We're going to keep ourselves, we're going to turn due east along the 90-degree heading, or as close as we can get to it. So we're literally just tilting very slightly over. We just need to throttle down. We don't want our speed to go too much above 200 meters per second before we're at 5,000. When we get to 5,000, we really need to start tilting over much more quickly, but not too quickly, otherwise we'll flip out of control. Yeah, we ain't going to get vaguely close to orbit with this. But you know, we've done a bit of a flight, so that's good. Okay, so we're still tilting very slowly. We're at 10,000 now, but we're not really... we need to be at 90 a little bit earlier than that. Yeah, we're not going to get very far with this. We might just about get ourselves into space, possibly. Okay, I'm just going to throttle down a little bit more. Simply because I just want to get a little bit more control back. There we are. Okay, so we are at 90 degrees. I'm going to hold it there. Although I don't think we're going to get very much further before we run out of fuel. Keeping that throttle actually quite low because the thrust to weight ratio is so high. As we're climbing up. Well, we've got a reasonable altitude, but we ain't going to make orbit. Well, actually, well, let's give it a try. Let's get rid of that, and let's switch over to our little rocket engine. Obviously, I've got to be careful of my fuel usage here, because this is my fuel to get back. I'm going to try and follow that yellow circle, but I'm not going to follow it too religiously. Just have to increase my throttle a little bit here. This isn't a very powerful engine, it's only really designed for use in orbit, not to carry on getting us towards orbit. Yeah, this ain't going to make it. I don't even think we're going to get to space with this. If we just go into the map view, you can see our flight path. Our AP is our apoapsis, that's the highest point in our orbit. That needs to go above 70,000 meters for us to be counted as being in space. And then obviously we need to bring our periapsis, which is the lowest point of our orbit, up above 70,000 meters in order to be counted as being in space and in orbit. Okay, so I am going to start following that yellow circle. Basically, if you go past the AP, you will start to descend, and you'll probably find you won't be able to achieve orbit if you haven't already done it. I've run out of fuel, so that's the end of that. So we haven't quite made it into space, but never mind. Where are we? We'll carry on with this. We might as well. Let's get rid of all of that, because that's no good to us anymore. You can see how the jettisoning works. Okay, and I'm just going to spin my capsule around. And you can see here we have a circle with the three little triangular prongs on it. Basically, what these mean, that means that we are facing backwards along our orbital path, and the other one means we're facing forwards along our orbital path. They're called prograde and retrograde. So prograde, we're facing forwards, and retrograde, we're facing backwards. So if we turn prograde and perform a burn, our orbital speed will increase, and our orbital altitude on the opposite side of our orbit will increase. If we burn retrograde, we will decrease. I'll show you that when we actually get to orbit, which we ain't going to do on this flight. So let's scrap this. Let's revert the flight back to vehicle assembly, because it ain't worked. Okay, so let's get rid of all this. take that back up again. So we need another stage basically. So what we're going to do, back to structural, another static decoupler, and we'll put another stage on. I think I'm probably going to need another 800, and I'm going to go with another 400, so a little bit more fuel, and another engine. We just need to lift that up out of the floor. There we go. Okay, so you can now see we've got 4,516 meters per second. Our thrust rate ratio is a bit lower. I think what I'm probably going to do, let me put some stabilising fins on this. Put 4 on. I think I'm going to put some solid rockets on. So if we go back to where is it? Utility. Get ourselves a couple of radial decouplers. Where are they? Oh no, hang on, they're in structural. Okay, radial decoupler. Basically, that allows you to attach something radially around the side of your rocket and detach it. So I'm going to pop 2 of those on the side of the rocket. Let me just zoom in so you can see what I'm doing. Okay, so we've got 2 of those. Go back into engines. Find ourselves a couple of hammer solid fuel boosters and attach those to our radial decouplers and just check that they are straight, which they are. And just for aesthetics, let's put a couple. Oh, shall we use those? Yeah, let's use those. There we go. So there's a couple of nose caps, aerodynamics. Okay, so that gives us nearly 5,000 meters per second and a much higher thrust to rate ratio. Obviously, these won't burn for very long. Okay, let's get our staging sorted out. So, rockets are going to ignite first, then they'll decouple. We probably want the liquid fuel engine to ignite at the same time before they decouple. Then we want that to decouple and that engine to ignite on the same one, and then there we go. So that's our staging diagram sorted. We just need to put a couple of launch stability enhancers so it doesn't fall over. So 2 of those, and we want those to release at the same time as everything else. There we go, so we've got all of that happening at once, and that will release the rocket. So let's try again. Take 2. See if we can get to orbit this time. This is what Kerbal Space Program is about. Have a bit of fun, trial and error, experiment. You know, if it don't work, well, never mind. Try again. Just keep trying, you'll get there eventually. Okay, here we go again then. We'll try this again. So, turn on stability. We probably want to put our throttle up to 100% this time because we've got a bit of a heavier rocket. Let's just go back into map, reactivate the nav ball, and just orientate ourselves because we're going to need that in a minute. Okay, let's come back out of map, and away we go. And as you can see, we've got those solid rockets. They're really kicking us up, picking up a lot of speed. Probably throttle down that main engine. Let's do that. Oh, they're burning a bit longer than I thought they were going to, I have to be honest. Let's completely throttle that now. Oh dear. Oh, right, let's get rid of those. Okay, let's get this main engine burning. And we need to tilt ourselves over quite quickly now. We've certainly picked up some speed. They burnt for a lot longer than I was expecting, I have to be honest. Okay, we need to keep the throttle virtually at 100% on lots of things. But you can see we've already gone a lot higher. Whoops, we're not quite so stable as we were last time. We're rolling a little bit. Just working everything just to try and keep it. There we go, straight and level. So let's keep flying along that path now. Okay, we are leaving the atmosphere. I'm just going to start tilting down and following that prograde a little bit more closely. Let's come out of map. Okay, you can see there that we are picking up altitude. what I'm going to do is try and keep the time to apoapsis, which is that number there, t minus 32. I'm going to try and keep that below 45, but not much lower than 30. I'm going to do that by controlling the throttle. So we go on to our second stage. Do that by controlling the throttle and by controlling the angle that we are tilting to. So we're trying to follow that prograde and keep our apoapsis there. So let's just throttle off a little bit. Take it down to about half power. We'll just keep going. Probably going to hold it at about there. Okay, need to keep, oops, we're going a bit fast. We're experiencing some heating. We're going a bit quick. Still quite low in the atmosphere. She's going to tilt upwards slightly so we can get out of this atmosphere. I haven't done this for a while, so I'm not 100% getting it right. Okay, so if we watch what's going on here, our apoapsis is currently at 52 and it's climbing. We need to get that above 70. That's a bit better. Okay, we just need to keep very careful eye on our throttle now, because you can see that time to apoapsis has increased. We're going to decrease the throttle to bring it back down a bit. We're still climbing, which is good. I'm gonna keep it at around about that, I think. Climbing up, climbing up, climbing up, climbing up. Increase the throttle just a little bit. As you can see, that blue orbital band is slowly getting larger around the planet. And our apoapsis is slowly increasing. Just need to keep an eye on that fuel. Still doing okay for fuel. Just need to tilt this down a little bit. We're going up a little bit too high now. Let's just bring this down. Okay, so we're now at 62, so we're nearly there. Okay, I'm going to bring it down onto pretty much onto prograde now. Just keep that throttle very, very low. Still climbing. Jeb's quite happy. Never wipe the smile off Jebediah's face. Okay, we're getting very close to the point where I need to consider cutting off the engine. But right now we're just going to let it keep going. When that gets to about 75, I'm going to cut the engine. Which you do by pressing the X key. Okay, yep, so we'll cut the engine. And we're now going to coast, because we don't want our apoapsis to increase any more, but we've still got to get our periapsis up. We're not actually in orbit yet. We're in space, but we're not in orbit. Actually, at the moment we're not in space, but we will go to space. So at the minute our actual altitude is 66, but we will go up to 76. Let's keep going. We've got 3 minutes until we get to our apoapsis. When we get there, we're going to do a burn, or just before we get there, we're going to do a burn prograde. So on the little circle with 3 straight little marks on it, the prograde marker, we're going to do a burn prograde, and that will insert us into orbit. So we've got a couple of minutes to wait, so we'll probably fast forward through this. See, normally I time warp through this, but since my throat is rubbish, I can keep coughing whilst I've got it muted and fast forwarding the video. See, that's why I'm doing it. This headset really starts to hurt your head after a while. Yeah. Okay, we have a minute to win it, so what we're going to do, we're going to keep an eye on this. When we get to about probably 20 seconds, we're going to do a fire prograde. So we need to get ourselves on prograde, and this is where we can use our sort of auto stability bit. So let's press the prograde hold, and that'll hold us on prograde, so it won't drift off. Just have to be a bit careful because it will be using electricity. As you can see, the electric charge is from the pod, and we don't have solar panels, we don't have anywhere recharging it other than the engines. So, just need to be careful there. Okay, our time to apparatus is now 20 seconds, so I'm now going to do a burn. And we're going to stop that burn there. Our periapsis is 74, our apoapsis has gone up to 83, so it's not a perfectly circular orbit, but we are in orbit. So, let's come out of that. So we're in orbit, so what we're now going to do is detach the rocket. Get rid of the rocket, we don't need that anymore. In fact, to be honest, we probably could have ditched that before we did our insertion burn and done the insertion burn with this little rocket, and that then would have meant that this re-entered and we didn't clutter up space, but you know, we don't care about that too much. Okay, so you can see that the engine nozzle is going mad, and that's because of prograde hold. Prograde hold will use any stability control that you've got, including the engine gimballing. So the easiest way to get out of that is to lock the gimbal. So that just stops it from flying around all over the shop. And we can hold ourselves in prograde mode. So we are in orbit. So now we're in orbit. There's a few things we can do. For a start, Jebediah can get out. There's Jebediah. He can get outside, we can turn some lights on him. And in fact he can let go as well if he wants to. There we go, so we are now out and free flying. I shouldn't have done this because I utterly hate spacewalk EVAs. The controls are really fiddly. Yeah, and that happens, you see. Back a little bit. Grab. You didn't grab it. Come on, quick. We've got to go forward before we lose the capture. Come on. Grab. Thank you. Oh, no. Yeah, you got it. You got it. Yeah, beat board. And we're back in again. Whew. Okay, so we're in orbit. Let's have a quick look at our orbit then. So this is our orbital path. And you can see we have a periapsis of 74, which is the lowest point in our orbit, and an apoapsis of 84. So I'm reasonably happy with that. If you wanted to correct your orbit, what you can do, when you get around to apoapsis, you can fire prograde very slightly, and that will increase your periapsis a little bit and circularise your orbit. So I think I'm actually going to go ahead and do that. So let's warp to apoapsis. It'll come out of time warp. There we are. So pretty much at apoapsis, so very quickly now we just need to get ourselves prograde and just do a little burn. 84, 84. That's pretty much as circular as you are going to get it. 847, 844, 845, 847, 848, 847. So that's pretty much as circular as you're ever going to get it. So that's pretty good. And again, if you needed to reduce your orbit, you would fire retrograde the other way, which would reduce the orbit on the opposite side of where you are. So it's important to remember that. If you do a prograde or a retrograde burn, it will always affect the opposite side of your orbit to where you are. Okay, so there you are, basics of getting into orbit. So we are in orbit. Next thing we need to do then is get back down again. I'm not going to worry too much about doing a precision landing, but what I am going to do is try and land in the daylight if I can, and I definitely want to land in the water. Like Earth, Kerbin is 70% water, but I usually miss it. So I'm going to use time warp, because I just want the biggest body of water that's available just to come into the daylight so I can see what I'm doing. Because we're quite low orbit, we can't time warp very quickly, but this is where I'm ultimately aiming to go. And what I've found is you need to aim for an altitude when you do your burn, a periapsis of about 34, roughly a quarter of the way around the planet from where you're actually aiming to land. Was it about 34? I haven't done this for a while, I can't really remember. I think it was about 34. Oh well, we'll find out. Is it about... no, it might be a bit lower than that. Ah, yeah, well, we'll find out in a minute. Okay, so what I'm going to do is I'm going to aim to land about here. So what I want to do is drop my periapsis about here, which means doing the burn roughly over here. As the planet rotates. I'll do our burn about there. I hope. No, I think I've gone too far. Ah, what the hell. Let's do it. Right, so if we now look retrograde, and we're going to do a burn. So let's do a burn. I'm just going to click to this so you can see what I'm doing. There we go. So the engine's burning. And you can see our periapsis is dropping. And I'm going to stop it. I'm going to drop it to about there. About 30? Yeah, we'll say about... no, about that. Okay, so we're now on re-entry trajectory. So we're now going to re-enter Kerbin's atmosphere. When we get round to probably about there, we'll start to encounter the atmosphere, I think. And as we hit the atmosphere, it will start to slow us down. And as we slow down, our periapsis will move, and hopefully we'll land in the water. We probably won't. We'll probably land on the land because I'm rubbish at this, but never mind. As long as we get back in, that's fine. Okay, so now we've set ourselves up for landing, we can go retrograde, and we will jettison our engine block, because we don't need that anymore. So that's activating the next stage, and that's activated the decoupler. So now we are just the command pod on our own, heading towards Kerbin. And what I am now going to do is just rotate so that we are upright in the nav ball. So that just makes it a little bit easier. And I want to get myself on that retrograde marker, and I want to hold myself on it as we come in. So this is how you do a basic orbital re-entry Kerbal Space Program. In future missions we'll probably speed all this up a bit, but you know, this is our mission for today, is to get ourselves to orbit and back, and that's what we're doing. So yeah, there is a little bit of that's time warp. We're going to be here all day otherwise. So let's time warp round. When we hit, obviously when we drop below 70, we drop out of time warp because we are now dropping into the atmosphere. So it drops us out of time warp. Whoops, this is a bit sensitive, this capsule. There we are. Let's got ourselves back on the retrograde marker. So we're starting to re-enter now. We're below 70,000. we're going to go into physical time acceleration, which is a different form of time warping. You want to be very careful doing physical time acceleration with large spacecraft, but this capsule's absolutely fine. And we'll just keep doing this basically until we... Whoops! Yeah, don't ever do that when you're in time warp! Yeah, I didn't want to do what I just did. And I bet you the battery's gone flat, hasn't it? Yes. Excellent. Okay. This could be fun. This could be an awful lot of fun. I'm hoping this self-centers. Okay, this could be entertaining. Oh, this could be really entertaining, this could. Okay, what's happened here is the batteries have gone flat, so I have no stability control. And I actually don't have any kind of attitude control really either. And we are tumbling into the atmosphere. And that was all because I pressed the button to tilt it up when I was in physical time acceleration. Yeah, you don't want to do that. Okay, so we're at 56. We're going to start hitting the atmosphere fairly soon. And I'm hoping when we do, we'll start to aerodynamically stabilise and sort ourselves out. I'm hoping anyway. Either that or we'll burn up, one or the other. If we burn up, what will happen is I will declare this video a 90% success, and we will try not to burn up next time. We've stopped tumbling quite as much, we've slowed down, but I still can't really stop it. Okay, we've started to re-enter, and we really want to make sure it re-enters that way. Oh, I think we're gonna be lucky. We're gonna be lucky, I think. I think the aerodynamics are gonna come to our rescue with this. If we were doing a re-entry from the Mun, we'd be in serious trouble at this point. Yeah, the aerodynamics have rescued us. We're alright. The aerodynamics have rescued us. We are coming in. Heat shield first. Not parachute first, which would have burnt the parachute off. Okay, we're just about going to get away with this, I think. This is not an ideal re-entry. You don't want to be bouncing around and tumbling all over the shop. That's not how you're meant to do it. But never mind. Don't worry about that. Ignore that. Aerodynamics take over at this point. We just got to let it do its thing. I'm actually sitting back in my chair, hands nowhere near the controls. I'm letting aerodynamics do their thing. What's the phrase they used on Apollo 13? Isaac Newton is now in the driving seat. Okay, so we're re-entering into the atmosphere. As you can see, we get the re-entry heating, and you can burn up if you're not careful. Particularly coming back. You see, I am gonna land on the land. You can burn up if you're not careful. Particularly from sort of coming back from the moon or things like that. You can very easily burn up. There we are, we're properly stabilised now. So we're properly coming through the atmosphere now. We're really heating up. If we look at resources, if you had a heat shield, you'd have ablative material as an extra resource, and you could see it going down. Obviously, if it hits 0, your heat shield fails, and then it's down to whether your capsule can withstand the heat. This particular capsule has a built-in heat shield and can come through the atmosphere from a normal orbital re-entry without needing an extra one. So what we need to do is wait for it to slow down. You see the temperature gauge there? That's indicating we're getting a bit hot, but we should be alright. At least I hope we are. It'd be quite embarrassing if it turns out that in a recent update that I haven't paid any attention to, they've removed the inbuilt heat shield from this capsule. That would be embarrassing. I'm starting to get worried they might have done. So it's getting a bit hot. Oh, I'm properly starting to lose my voice as well, I'll tell you what. Apologies if I've been babbling a little bit in this one, but my voice is all over the place. Okay, so we're coming in. We are definitely landing on the land, so I've properly mucked that up, but never mind. We'll be good, we'll be fine. We can land on land. It is getting a bit off actually, but we're okay. We're alright. It hasn't hit the red at the end yet. And we are slowing down. As we fly through the atmosphere. Our little rocket, the other part of our spacecraft, the engine and fuel tank, will already have re-entered and probably burnt up, probably exploded. They don't always do that, it does depend on your re-entry speed and everything else, but I suspect it probably has. Ah, there we go, we're through the atmosphere, we're slowing down. We're now below 1,000 meters per second, we are at 15,000 meters above sea level. Obviously our height above the ground is a little bit lower than that because we're not over the sea, but that's not a problem. Okay, you can see over here the parachute icon is red. If I activate the parachute now, they will disappear behind us and sort of go on their own merry way. We don't want that to happen, so we've got to wait until that is no longer red before we can press the staging button to activate the parachutes. Usually I think it's when you drop below about 250 meters per second or something like that. Oh, there we go. So we can now activate the parachutes. I'm going to leave it a little bit longer before I do. Jebediah is loving it. Okay, I'm going to activate the parachute now. There's the parachute. Parachute will fully deployed about there. That really did leave it until the last minute to deploy. I tell you what, 200 meters I think above the terrain. But there we are. We've dropped to a nice, safe, speed. We are descending on our parachute back down to terra firma. Not very far to go now. Okay, so you get the basic idea of how to do this, and obviously as you start building more complicated vehicles, you know, things get a bit more complicated. In our next mission, you'll see we'll build something a bit more complicated, and we'll go off and do something a little bit more sophisticated with a little bit more sophisticated landing. But there we go, we're about to hit the ground, and there we are, safely landed. And in fact Jeb can get out, and he can jump off, he can fall over because he's Jeb and that's what he does. And in fact even on the planet Kerbin we can walk over here and we can plant a flag. There you go. Let's plant ourselves a flag, and we shall call it First Orbital Landing. We didn't explode. There we go. So there we go, that's our first mission done. So what we've basically done, we've flown up into orbit, we got into orbit, we've come back down again. Very straightforward, very, very simple. Hopefully future missions that I do, we won't be quite so, you know, we'll fast forward through a lot of this kind of stuff, but I wanted to show you exactly how to do this, even though it was a bit slow, took a bit of time. I want to show you exactly how to do this. So we've got ourselves into orbit. You now know how to launch a rocket, how to get it into orbit. What we're going to do next, we're going to do a more complicated mission. We're going to go to the Moon, we're going to fly to the Moon, we're going to land on the Moon, and we're going to get back again. So moon landing basically, that's going to be interesting. We're going to do it slightly differently to Apollo, but I'll talk about that next video. So again, thanks for watching, and we'll see you again soon with some more Kerbal Space Program.